Okay, so myself Naveen Kumar Saini in the course Wireless and Mobile Communication, code KEC 076. Today we will discuss about the very important topic, that is cellular infrastructure. So what is cellular network? We must know first, and what is the importance of cellular networks. So then we'll go through the infrastructure part of this topic. So cellular network, which is an underlying technology for the mobile phones, personal communication systems, wireless networking, etc. And in that technology is developed for the mobile radio telephone to replace high power transmitting receiver systems to the low power transmitting receiving systems. Cellular networks are used for low power, shorter range, more transmitters for data transmissions. So what is the main purpose of cellular system is to utilize the given bandwidth in a very efficient way. Plus, how we can increase the data rate. Third, how we can reduce the interference. So these are the few factors which motivate us to talk about the cellular systems. So in modern cellular telephony, or the rural urban regions which are used, and it is divided into the areas according to a specific provisioning guidelines or the standard protocols. So cellular system in which in a given if we have a given coverage area which is of maybe the macro cell, so we divide the macro cell into the micro cells based on the geographical regions, just like rural areas, urban area, or the suburban areas. So based on that area, we different standard protocols, we use the cellular system, and the division of the cellular systems also takes place into that way. So method, cell splitting, and the cell sizes, which are very important, which plays a very important role to design the cellular system. So in that, some key terms are there, that what is the cell, clusters, frequency reuse, and the handovers. So what is a cell? So some terminologies we must know. First is what is a cell? Cell is the basic geographical unit of the cellular system, and this cellular system term comes from the word that is honeycomb, or the hexagonal shape of the one cell. So which is nothing but this is the coverage region which is divided theoretically. Okay. So then cell wise, one base station provide the transmission over a small geographical area. So when we say the cell, it means there is a one base station which is into it. So due to the constraints which imposed by the natural terrain and the man-made structures, then the cell which are not perfect hexagonal shape. So as we said, this is completely based on the geographical area. Maybe some plain area is there, or some hilly area is there, terrain is there. So based on that, this theoretical shape, that is hexagonal, is not completely hexagonal shape. So but theoretically, for calculation point of view, we consider this which is of high coverage area. So hexagonal shape is used for the cell. Second is the size of the cell, which depends on the density of the subscriber in the area. So whatever cell size, as we must be aware, the cell size is not, cell is what? This is the cell, and in the center we have the base station, right? So which is used as a transmitter, and the user which is a mobile phone. So this is the receiver. So this cell size depends, this cell depends on the numbers of users or the subscribers. So based on that, the cell size is decided. So the capacity of the network in the densely populated area can be improved by reducing the size of the cell, or by increasing the number of cells along with the installing low power base station. If we split this base station into the smaller base stations like that, so in that way the number of cells will be splitted, and the more number of cells is there. When we say the more number of cells, it means the more number of allocated channels will be there. So if the more number of channels are there, it means the more subscribers can be accommodated. And this base station, which is for the, you can say this is for this is the macro cell. Okay, so this is a macro cell. The very high power transmitting antenna is required, but when we have a smaller cell like this, so in this case we require the smaller cells, smaller low power base stations, to which is used to increase the capacity, or the more number of subscribers can be accommodate into the this cell. So based on the size of the cells, we defined in that way, it categorize macro cell, which is the largest area of the cellular system, micro cell, these are lesser than the macro cell, pico cells, and then femto cell. So this femto cell is nothing but this is the very smallest unit of the cell. Okay, so macro cell is the biggest one, coverage area of the hexagonal shape. Micro cell is smaller than this macro cell. Pico cell is again smaller than the micro cell, and the femto cell is again lesser than the pico cell. It is based on the kilometers range, we can say. If we have the few meters or maximum 1 kilometer, then femto cell is used. Then if we have the industrial area kind of, or you can say the building area kind of, so in that case society, the pico cell is enough for that. Macro cell, industrial area, or we can say this for the city, we use the macro cells. Okay, maybe on 20 kilometers and 20 kilometers and so on. So this cellular, in that third terminology is the cluster. So cluster is nothing but this is a group of cells. So group of cells from a cluster, and the size of which is denoted as the n. So no channels are reused within a cluster, and 7 cell cluster, each cluster is allocated a set of frequencies, and L is restricted by the following equation. So what is the meaning of this? What is a cluster? Cluster is a set of cell or group of cell in which the different frequencies are used. No same frequency will be used into the same cluster. Just like in this diagram, we can see if this is the cell number 1, so here value of n is 7. So 7 cells cluster is there, in which the cell number 1, this one, the frequency f1 will be used. Cell number 2, frequency f2 will be used. Cell number 3, frequency f3. Cell number 4, frequency f4. Cell number 5, frequency f5. Cell number 6, frequency f6. And the cell number 7, frequency f7. So it means we can say in a given band of frequencies, we divide this band of frequency into the 7 frequencies. So in that case, these 7 frequencies are different. We are not using the same f1 frequency in any of the cell, right? So every cell is defined by the different frequencies, f1 to f7. So same frequency we are not used, so we call it as a cluster. One cluster, different frequencies. So cluster size, as we said about the n is equal to 7. So how we are getting this? I mean, in a one cluster, how many cells are there? So for that we have one formula. This is the I square plus j square plus ij. So based on this value, we define the value of n. So suppose I is equal to 1, okay, and j is equal to 2. So in this case, what we are getting? So here we can say this is the 1, this is the 4, and this one is the 2. So this value is nothing but the 7. So it means the value of I and j must be 1 or 2, or optionally I can be 2, and then in that case j is equal to 1. So if this is the value, the value of n will be like this. So based on the value of I and j, we can find the value of n, which shows the one cluster comprises 7 cells. So in that, what is the I and what is the j? I is the vertical move and j is the slant horizontal move. Now come to the next point, that is frequency reuse. So this frequency reuse is nothing but this is the how we can use the same frequency into the another cell. If we see f1 frequency is here, right? So if we are saying the frequency reuse means same frequency f1 where or in which cell we can use it, because in one cluster we are not using the same frequency. But if we can utilize this f1 frequency in any other cell, it means it will be into the any other cluster, right? So in the next cluster we can use the f1 frequency. So in this case, we must know the hexagonal cell shape is conceptual and it is simply It is a simplistic model of the radio coverage for each base station. As the radiation from antenna is circular, so thus there is a fading on the edges of the triangle and square. In hexagonal shape, the lesser fading on the edges, and when using the hexagonal shape cell, base stations area are depicted as either being in center of the cell, center excited cell is there, or on the 3 edge of the 6 cell vertices edge excited cells. So here we can see, so in this case, if the first scenario will be if the base station is lying at this point, right? So this centrally excited cells, and if this one is 1, 2, 3, 4, 5, 6. So we have the 6 edges on which again we can center this base station. So this base station can be at this edge as well. Okay. So this is called the edge excited cell, center excited cell or the edge excited cell. So for center excited cell, omnidirectional antennas are generally used, and for the cell excited cell, the sector or the directional antennas are used. So this method is used in the sectoring when we accommodate these antennas at the cell edge. But when the base stations are installed or the deployed at the center of the cell, so this is the center excited cells. So it is representing here. So in this, the cell excited cell is this, where the base station is lying at the center of the cell, where the omnidirectional antennas are used, and in the edge excited cells, so these base stations are connected at the cell edge, right? So these are the antennas which is connected there. So these are edge excited cells. So in this we can see here as the next point which is important for the reusing the frequency, we call this concept as the frequency reuse or the frequency planning. So frequency reuse, in that frequency reuse, as I said, if we want the same frequency f1, we want to utilize the frequency f1 here, then it will be utilized here same frequency, and here itself we will use the same frequency f1. So this is the first cluster, cluster number 1, and this one is another cluster, cluster number 2, and this one is again next cluster, cluster number 3. So we want how we can plan the frequency management so that the same frequency f1 is used into the next another cluster, right? So this is the requirement for the when we do the cellular deployment. So in this way, the each cellular, so we call this distance, frequency distance is what? This is the distance from this A cell to A cell. So this is the D. So what we want, we actually want in which cell the same frequency is utilized. So this distance is called the frequency reuse distance. So each cellular base station is allocated a group of radio channels to be used within the small geographical area is called the cell. Means in that group of radio channels which is used in the smaller geographical area, that is called the cell. See, so when we say the cell is what? Where the base stations are installed, and second, when the base stations are there, it means the number of channels can be allocated by the base station with the help of MSCs. So the base stations of the adjacent cells are assigned the channel group, which contains completely different channels, and then the neighboring cells. So if n cells which collectively use the complete set of available frequencies is called the cluster, right? So different frequencies, as we said about the definition of the cluster, right? So here is the example of when the n is equal to 19. So as we said before, that n is what? N is nothing but I square plus j square plus ij, right? So in this case, we can see when the I is equal to 3 and j is equal to 2. So this value we will get the n is equal to 19. So what it shows, when n is equal to 19 is that this is the one cluster. So cluster of cell 19. So if we count these numbers, right? If we count these numbers, then in this case cluster size will be n is equal to 19. So 19 frequencies are used in different cells in a cluster. So how it is representing if f1 frequency is here, and what we want the what is the frequency reuse distance. So this is the frequency reuse distance D, and here itself frequency reuse distance D, and from this point to this point frequency distance D, and from this point to this point this is a frequency reuse distance D, and same way here, right? So this is the frequency reuse distance. So we see in the, if f1 frequency is utilized here, then in that case the same f1 frequency will be here, f1 frequency, and the same frequency will be allocated in the co-channel cells, right? So this is understanding of this n is equal to 19 structure. Sometimes in exam they ask to draw this. So we see, if we do this in the we can do this in this way. So when the n is equal to 19, then in that case how many cells are there? 1, 2, 3, 4, 5 and 6. So we have the 6 co-channel cells. So whatever number n is equal to 19 or n is 7, in that case the co-channel cells are always 6 in this case. So this is the tier 1. This is the case for the n is equal to 19. So this is the first tier or the tier number 1. Similar to that, again we will have the tier number 2 and then tier number 3. So in which the same number of co-channel cells are allocated. So the now question arises, how we are reaching this point, from this point to this point. If we want to move from this point to this point, it means we have to follow this path from this point to this point, and we have to follow the same path. So what it shows, this is the value of I and this is the value of j in the same way, right? So how we can find this? So to this is a relationship exists between the cluster design equation and the frequency reuse as well as the frequency reuse distance. So to find the nearest co-channel cell, as we said, we have to move I is equal to 2 cells along any of the chain of the hexagon vertically up and turn 60° clockwise and move j cells. What it shows, as I said, we have to move the value in terms of j, I and j. So I and j is nothing but this is the distance between the base stations. Suppose we are here right now. So at this point, from this center to this center, so in this case the I is equal to 1, and this point to this point again I is equal to 1. So it means from this point to this point the I value is 2. So as I said, I and j, these are the distance between the base stations, but there is a movement how we are moving. So when the I is equal to 2, it means we are moving from this point to this point, 1 and then I is equal to 1 and then I is equal to 2. Now what we have to do, we have to move clockwise direction 60°. So when we are moving now from I to j, so this j is what? J is equal to, we can see j is equal to 1. So when the j is equal to 1, it is j is equal to 1. So it means this is the cell again where the same frequency are utilizing. Same frequency is utilizing. So this is the co-channel distance. Okay. So this is the co-channel distance which we can find in any way. So when we are moving from this way, or we are moving from this way, and we are moving from this way, and so on. So in this way, what we will get? We will get the same thing, right? F1 frequency here, F1 here, F1 here, and then F1 here in similar fashion. So in this way, the same frequency F1 will be there, and again it will create at the first tier of the communication system, right? Or the co-channel cells. So this is the way how we can, this is a thing which is mentioned here for a given set of frequency F1 to Fn in the co-channel cells. So to find the value of n in a cluster. Okay. So this is a simple example for the 3 cells, and this is the example for the 7 cells. So in this case, the cluster size is n is equal to 3. Sorry. Okay. So here the cluster size n is equal to 7. Right. So there is a channel statement assignments, so which we will discuss in the upcoming lectures about this, but we have to stick up to here because this is the first section of this video in which we must know how the co-channel distance can be find out. Okay, thank you very much.